Hi everyone. First and foremost, I'd like to thank you all so much for coming. We're all really excited, not just myself, but also our wonderful panel, to introduce you to actually the wonderful world of engineering and maybe teach you something that you don't know. So, as we all know, engineering is quite a misunderstood profession. Most people see engineering as with an image of hard hats, high vises, manufacturing, sitting behind a computer, geeking out, coding, etc., etc. But I promise you it's not exactly what you think. There's so much more to this wonderful world. And we have such a mixed batch in our panel of engineers to actually tell you exactly what it is that they do. So for example, growing up, I didn't know what engineering was. I never really heard of engineering until I went to university, but that's a different story. But I remember going to university and telling my mum, oh, by the way, Mum, I'm going to go study engineering. And she was like, oh, okay, what's that? You know, kind of like all she knew was kind of builders bums, high vises, not a girl's thing to do essentially. But there is a funny story though. I remember when I was at university, my mum called me and she said, Mimi, the car's broken. I went, all right, well, you need to go and call someone to ensure they can fix that. She went, yeah, I'll definitely do that. I said, okay. This was 2 months later, I came back from uni. And I said, Mum, the car's still broken. She went, yeah, I told everyone that my engineering daughter is going to fix the car. And that's when I kind of knew that, okay, not everybody knows exactly what engineering is. So I think panels such as this, talking to people and just learning about the different options that are out there is really, really important. And also for the sake of my mother. But today, anyway, we're here to kind of shed the light on exactly what engineering is. We have a fantastic panel and I'm super excited for us to bust all of these myths and potentially answer the questions that our lovely participants may have for us too. So, I will begin by introducing our panel. So we have me, your host, and we have Rhys Morgan, who is a director from the Royal Academy of Engineering. We also have Ajani, who is a process engineer and the co-founder of Black Women in Engineering. We have Neera Kukadia, who is a project engineer at the Transport for London. Thank you for nodding. And we have Crichton, who is from the head of engineering and who's the head of engineering. And finally, we have Damilola Fari-Arole, who is a systems and RAMS engineer at Network Rail. So as you can see, we have a fantastic array of engineers who will be more than glad to explain their roles to us and help us bust the myths that we have today. So let's begin. So our first myth is number one. So as I explained earlier with my mother, is that engineers can fix everything. So people, when they hear engineering, they think, okay, they must be able to fix my car, they can fix my radiator, they can fix all of these things, but can we actually? That is the question. So I'm going to hand over to our panel. So if anyone has anything they'd like to share in relation to this myth, any stories or anything that's something like my mother maybe.
Yeah, I'll go. So I work at TfL at the moment as a project engineer, but my background is mechanical, so I'm a chartered mechanical engineer, and I studied that at university as well. And my parents, similar to your mum, just didn't know what it was, and when I first told them, they were a bit kind of shocked, like, oh wow, what is this? She's never spoken about it. And then when I was at university, my dad would tell all his friends, you know, really proud that, oh yeah, my youngest daughter, she's now studying mechanical engineering, and one of his friends, who's actually a mechanic, said to him, oh, that's great, so she's like me, she's a mechanic. And my dad told me that, and I went, Dad, did you tell him that he was wrong? Because I don't know how to fix the car, and I wouldn't know the first thing. I hope people don't think that. And he was like, no, I thought it was like the similar sort of thing. And I was like, oh God, that's when I realized as well, I need to kind of talk to my parents about what I really do.
I think it's so funny because I feel like with engineering, it's cars that is the epitome of it all. It's like, can't fix the car, you can't be an engineer. It's actually quite funny if everyone has a similar story with that car analogy, but anybody else?
Interesting you mentioned car there because of engines, and we often think, you know, the thing about engines and engineering is that the association with engines, but weirdly the word engineering comes from and the word engineer comes from ingenuity, and it's actually a Latin word, ingenium, which is much more to do with creative problem solving. But having said that, I'm also really rubbish at trying to fix stuff. So So theoretically, I know why my central heating boiler is broken, but I can't fix it. I need to call a plumber, and I love plumbers, and plumbers get a hard press with engineers because everyone just says, well, you know, everyone says, oh, like when you get the engineer around to fix your central heating system. I love the plumbers who come and fix my central heating system because they're actually using real engineering problem solving.
Yes.
They might not be classed as graduate engineers with the highfalutin title of chartered engineer or whatever, but they're still using amazing problem solving skills.
No, I definitely agree with that as well. 100%. They're very vital to society as well. So technically engineers too, they use the design from one engineer has designed the heating that they're fixing anyway. So they're just applying that skill. Yeah. Anyone else? Abby?
I was just going to jump in and say mine was slightly different. So my dad works in the engineering industry, so knows quite a lot about engineering, and he knows the difference. My mum not so much. And so growing up, I've always kind of liked fixing things, making things, opening things up, putting them back together, seeing if I've broken them or not. And so when I was in university and my mum's TV wouldn't work, and this is times when she needed to connect her TV to a laptop and you needed an HDMI cable. And she couldn't do it. So I'd come back from uni and, you know, we'd want to watch something on her laptop. And I say, oh, you can put that on your TV. She's like, how do you do that? So I connected it with an HDMI cable. She go, oh my gosh, this is amazing. Little did I know that she wasn't really learning what I was doing. So I went back to uni and I came back home and she goes, oh, so that thing you did the other day when you put my laptop on the TV, can you do that again? I'm like, it was just a cable, Mum. You could do it easily. She goes, oh, yeah, but that's why you go to uni. That's why I send you to university. And
yeah, that's it.
So I said to her, I said, look, I'm going to teach you how to do this, and I'm not going to charge you a fee because obviously I'm nice.
No, that's it.
But I did say to her, I said, like, look, if it's just a cable and you can connect in. Ever since then, she's literally loved me. So it's not quite the kind of engineering that I do, and I can't do every kind of engineering, but these are like basic skills. I don't even think you need to be an engineer to know how to connect an HDMI cable to your laptop, but okay.
No, yeah, it's those similar stories. Kind of like my mum, she's extremely proud. And very much doesn't really understand what I do, but she's extremely proud. You know, when she introduces me to new people, she goes, "My daughter's an engineer," and I'm like, "Mum, my name is Mimi, by the way." And I'm like, I have to like secretly introduce myself after and go, "Sorry, my name's Mimi. Sorry, pardon my mother." She's very proud, but you know, but it's probably just yeah. Anybody else? Emma?
I've got an interesting kind of thought on this question. So engineers can fix everything. So kind of I studied civil engineering at university, then got chartered as a civil engineer working in the water industry. So have been asked to fix plenty of toilets in my time and had to apologise that I can't. So one thing with engineers can fix everything is I think that you're told that you're a problem solver. And then, for example, if somebody's, you know, having a relationship problem or trying to understand something, like, right, Jim will fix it kind of mindset. And I think like understanding where the limits of engineering, that logical, critical reasoning are is really, really key. So there's like, you know, what is engineering and how can it help society and the environment and like kind of the people on the planet that we live on? And understanding where is that need for that kind of logical reasoning and support, but where is the need to kind of bring in voices that are not necessarily engineers as well to really fix the problem. So I'd say engineers have been told that they're problem solvers, but I think really need to kind of think about how they work with people more closely to actually really fix the issue at hand.
No, I agree. It's a number of things, engineering, though, isn't it? I mean, I can't fix your relationship, but I might be able to tell you how to design the foundation of your building, kind of, sort of. But, but thank you so much. Yeah, of course.
Build on Emma's point, though, because I think this is really important. You know, we are, you know, as humanity, we are facing, you know, the most immense global challenges now, and you only have to look at the kind of, you know, the sustainable development goals. And actually, a lot of them have engineering as a really kind of central component of them: clean water and sanitation, feeding, zero hunger, you know, feeding the world, clean energy, renewable energy, sustainable communities, societies, and so on. And engineers will have a really central role to play in a lot of those things. You know, we are going to be a very, very key part of the next 50 years of the globe. But I think it's really important what Emma says is that we shouldn't be arrogant about this. You know, we have to be humble, and we have to recognize that we don't have all the answers. And actually, these are really, really complex kind of challenges that require sociologists and psychologists and historians and geographers and all the different economists and all the different kind of disciplines to come together. And we will play a role, but we certainly can't fix them on our own.
So maybe as a collective, we can fix everything when we bring us all together, as you just said, but not individually. Individually, I can't fix everything, but as a collective, we can fix everything. Yes? No?
Yes, but I hope you can you can design the foundations properly.
Hopefully, kind of, sort of, maybe, with the help of a senior. But yes, thank you so much for the answer to your first question. It was really insightful. And the second myth that we have is you'll learn everything about being an engineer from university. So I can give an example of something roughly. I remember when I was at university, I kind of sat there and I thought, right, if I'm going to be sitting crunching all of these numbers, I might go insane. And I was like, wow. So I took a placement year. And then that's when I knew that there was so much more to engineering. So when I took a placement year, I did it in central London, and it was like opening up a new world. I was like, wow, there's so much to learn by being on site, and not even just the application of the theoretical knowledge of engineering, but learning from other people was extremely important in that time as well. So learning how people use this different terminology, learning how people speak to senior members of staff, learning how to network. And there was just so much that university didn't teach me as well, although the theoretical side of university was obviously very important. But I'm a strong believer that there is more to learn when you get to work. Even with the job I'm at now, when I finished my degree, I thought, right, I must be pretty decent at concrete, because I think like I know more than the average person about concrete. Then when I got to work and I met the concrete, I'm going to call him the concrete god with a small g. I'm going to call him the concrete god. And I thought, wow, this is insane. He knew things about concrete that I didn't even know existed. So there's so much to learn from other people, but definitely, yeah, I agree with that. Anybody else?
Yeah, I agree with that, because although I learned a lot at university and almost like the basics of maths and physics for engineering, it was mainly just on the job learning that's really been the key for me. So things that most people forget about engineers is that we need to know how to communicate, especially in modern day engineering. And it is about how do you build rapport with people, how do you get out technical information from the subject matter expert. And it's all these things that you don't necessarily get taught at university that you then have to go into the big bad world and realize, actually, I need to learn how to present. I need to learn how to technically explain something to a project manager who is not technical. So, it's all those types of soft skills, as people say, that are just as important as your technical skills that you actually learn throughout your career. And I think I'm, very early on in my career, and I've got so much more to learn. But it's exciting, because at least then, you're not stagnating, you just carry on learning. So, yeah.
No, I definitely agree with that, Neera. That's absolutely correct. Yeah.
It's a really interesting question, actually, because the thing about universities, I'm going to do a plug for TEDI here now, because TEDI is taking a very different approach to the way they're going to teach students compared to your kind of more traditional universities.
Yeah.
And your more traditional universities tend to have lots and lots of lectures where you'll do lots and lots of mathematics and lots and lots of kind of science and trying to underpinning theory. And the reason why they're doing that is because when you go into a job, they don't know what kind of job you're going to do, and they don't know what you're going to specialize in. So they have to try and teach you everything as much as they possibly can of all the different elements of being a civil engineer or a mechanical engineer or electronics engineer or whatever it might be. And they just have to cram as much in as they can in those 3 or 4 years that you're studying. So that you've got this kind of rough library of knowledge that you can kind of go back to. But actually what they don't teach you is how to be an engineer, weirdly. What they're doing is they're teaching you all the bits of knowledge to be an engineer, but not how to be an engineer. Whereas TEDI, actually, interestingly, is going to do away with all those lectures, and they're going to tell you, right, you're going to be an engineer on day one. We're going to give you a problem. You go away and fix it, because that's what engineers have to do. And we'll give you some pointers as to where you can find the right information, but we're not going to tell you what that is. You have to go and find out as well. And actually, so it's a really different, interesting model of teaching and learning that's happening in engineering. And TEDI is one of the real pioneers in the UK on this. And there's only a few universities now that are really trying this totally different approach to teaching and learning. So actually, it's really exciting the way they're going about it. So in one way, you do learn loads and loads of stuff, but actually loads of stuff that you'll never ever have to use again in your life. I've still got like just the terrible memories of Tuesday afternoons doing like maths that I just never want to actually ever see again. And I never will use again. So they did teach me all of that, but I've never used it. But actually they didn't teach me lots of stuff about how to be an engineer, which I really did need to know.
Yeah, I felt that as well. That's another reason why I wanted my placement year, because I was kind of a bit like, if I have to do all these number crushing for the rest of my life, I might scream. So, but then actually going to work and realizing that it was problem solving, and that's another thing at university as well. They teach you the maths and physics to get the right answer, but what if something goes wrong? There was never any contingency behind that, and there was no, how do you solve the problem if something goes wrong? But that's when I went on site and I saw all of those things happening, and I was like, wow, I don't have the knowledge for this. Great. So, but that's obviously something that you learn when you get to work, and you people learn from their mistakes. And obviously people who have been in the industry way ahead of you, they teach you about the mistakes that they've had from all their logs, all the things that they've written, maybe site diaries, etc. So yeah, it's pretty good. I definitely agree with that. Yeah. Abby?
I was just gonna jump in and say that I literally just echo what Rhys and Neera said. I don't think you learn everything about being an engineer from university. In as much as quite a lot of universities try to give you those, like, you know, learn how to use certain softwares that you need when you're studying. So I studied chemical engineering, and one of the softwares that we used at first year was CAD. If you ask me now, I've ever used CAD in my actual job, I've never used CAD. I have used Visio to do drawings, but never CAD. But there are other stuff as well that you learn, as much as you're learning about, you know, the jobs as well. There are other stuff that you can learn while being in universities that's not necessarily engineering related, but they go a very long way with helping you as an engineer. So that's teamwork. So I remember working in a project for my my design project. And like many other people studying, you've got like the people that are absolutely enthusiastic about the engineering project. You've got the other few people that just don't care so much. And then you find that some other people are doing a lot more work than some other people in your team. And then being able to manage that relationship is something that I know is definitely helping me in my actual work now. And that's not something that was in the curriculum. That wasn't something that the lecturer sat us down and taught us about. It was something that I learned while studying university. I think another thing that's very important, you know, from, you know, being an engineer and going to universities, back in my days, and I say this like I'm a dinosaur, I'm not, back in my days, it was like engineering, you can only study engineering as a student in university. But there's so many other alternatives to studying, you know, to being an engineer. Yeah. Very, very much like what TEDI-London is doing, and, you know, lots of people know about apprenticeships and stuff like that. I would go as far as saying that as an engineer, it's much more about your problem solving skills than it is your theoretical knowledge, because a lot of things that you're going to use your theoretical knowledge to do, someone else has already done it and created a software or created a worksheet that does the calculations for you. So you don't need to know about, you know, like Bernoulli's equation and stuff like that, as long as you know the principles. But if you're able to solve problems, then you're just as good as engineers as anybody else. And yeah. That's
No,
fine.
I agree. I've learned so much about how it's, for me personally, in my engineering, very short engineering career, I've only been engineering not that long. It's been more about my communication skills and how I can present, how I speak to people, how I solve problems, kind of, sort of. And, you know, like I said, it's kind of those things are already in place as a software that can do all these things. However, the contingency comes in if that software breaks down. Sometimes I think, are they going to rely on me with all the mathematics I learned from uni? I hope not. But yeah, so it's really has come down to kind of how you communicate with others, especially with that group work. That is very relatable to real life. I only thought that you may have some lousy people maybe at uni, but in real life they are the same. But yeah, so you do learn a lot from uni, definitely. So I'm very grateful at the same time. So.
Yeah, I just also like slightly disagree with Abby there. Sorry, Abby, but because I do think actually, you know, too much dependence on kind of software, and I've seen this as a teacher of engineers. So I was an engineering lecturer myself, and if you just use a piece of software and you don't know what you're doing with it, and you throw some rubbish data in, your rubbish numbers in, you'll get rubbish out. But you might produce a pretty picture and think, oh, that looks pretty good. But actually, it'll, you know, the bridge will fall down, or the, you know, it'll, the structure will collapse, or whatever it might be that you're doing. So I think, you know, there, to an extent, there are softwares and there are technologies that can do that, but you still kind of need to understand, you know, the principles behind it and know that, you know, what the answers that you're getting are roughly the right ones that you should be getting.
Oh
Yes.
yeah, absolutely. I definitely agree. It's just every single time you're doing, I don't know, you're sizing a pump or trying to design, I don't know, a vessel for a specific application, you don't need to go back to the basic calculations if you understand the principles behind it. And so, yeah, so then you won't be putting rubbish in to get garbage out.
No, I definitely agree. Thank you guys again. Should we go to the next myth?
Just a quick one on that,
Oh,
Mimi. I think
sorry.
that's all right. I think with, like, for example, if you substituted out the word engineer in that sentence for doctor, yep. I think people would quite quickly say, like, definitely not. Like, they need to have real understanding of hospitals and, you know, patient care and working with people, like real people. And I think it's the difference, like, of course, there's so much learning in the profession, and just practically you have so much more time once you get into the profession. You're spending 40-hour a week on a certain job in a certain area, whatever it is you're doing. Like, of course, you're going to learn more in that space. But I think what education does and what university does is kind of set that framing of thinking about things. It's kind of trying to prepare you for longer than just one job or just one project. It's thinking, like, what are the skills you're actually going to need for the next 20, 30, 40, 50 years? So I think that, and yeah, like, I think it's really exciting what TEDI's doing with project-based learning, because it's that practice of projects again and again and again, kind of pulling in relevant knowledge, being able to work in a team and thinking quite deeply about the impact of what you do. So, like, learning about the world. I know when I was at university, I learned a lot about just the world, and hearing different perspectives and understanding, like, where different people are coming from, and kind of really being open-minded about, you know, what can engineering do? What could it be? And kind of learning all of that stuff and being inspired as well. So I think I definitely debunk this myth, but I think that that's okay. Like, I think education and university serves a purpose that's not just, you know, training for your first job.
No, you're right, Emma. I think I loved what you said about being inspired, because that's what university definitely done for me. It made me think wider than just my first job. I thought, okay, so if I'm learning all different aspects of civil engineering, maybe in my first job I'm designing roads, but maybe I can design tunnels, or maybe I can do this, or maybe I can go abroad. Like, there's so many different elements in civil engineering that I could, you know, take the route of, and so many different countries that civil engineering is relevant in. So, for example, we did case studies on projects in Dubai and projects in, I never thought about maybe working in Dubai or anything like that, but university gave me the option to see myself actually working in these countries. So you're absolutely right. I definitely agree with that. Thank you. Should we go on to the next myth? So this is one of my favorites. So to become an engineer, you need to be great at maths and physics. So I'll go first. I'm not sure if people know my story of engineering, but originally I didn't apply to study engineering at university. I applied to study a more science-based degree after not doing so well at my A-levels and not getting into medical school. So I decided to study another science subjects and didn't like it at all. But prior to that, I didn't study maths or physics at A-level. I did biology, chemistry, psychology, and religious studies. And then thankfully, one of my friends came up to me as he was studying his civil engineering degree and said, "Do you want to come with me to one of my lectures?" Now, I didn't know anything about what he did. I didn't know anything about what he studied. And I followed him, and he did civil engineering. And I fell in love in 15 minutes. And then 15 minutes after the lecture, I changed degree. And that was that. Did I find it difficult? Yes, because I didn't have the basic foundations of maths and physics. However, my university were really good with people in the same boat as myself. In first year anyway, they teach everybody at the same level, where they assume that people don't have maybe a lot of maths and physics knowledge, or if they did A-level maths, they kind of build on that level. But I also took extra sessions. My university gave us the option to do extra maths lessons, extra physics lessons, so it helped me to even get to the first year level. So that was really good. But I, after that, didn't feel like I was lagging behind anybody. My university never made me feel that way. My peers never made me feel that way. And now I'm at work, don't really use maths and physics like that too much as I did at university anyway. Like I said, it's more based on my people and communication skills. So yeah, that's my view on this question. I don't think you need to be fantastic. I think it's good to have a basic knowledge, but not Einstein or anything. No. Anybody else?
Yeah, you go for it.
Okay. Yeah, I was just going to say, it depends on what kind of engineer you are, actually. If you're a design engineer, then you will need to have a good knowledge of, you know, certain kind of physics and maybe not necessarily just maths, but generally speaking, you probably won't need to be great at maths and physics. It'll be good if you're good at it. Interesting, my A-levels, I did your general kind of basic engineering A-levels. I did the maths, the physics, the chemistry, and a bit of psychology as well, because I've been a rebel. And then I wasn't very good at physics. I really did not like physics at all. So I dropped my physics at AS and did triple B Tech science for my A2, which was good. It saved me. However, when I got to uni, I didn't use as much physics as I thought I would. I thought I'd be calculating how to get to the sun, what's the speed of light and stuff like that. I didn't need that much maths. I didn't need that much physics, which was good because it was just enough physics that I can get my head around, but not too complicated because I'm not a physicist. But I'd still say I'm a pretty good engineer, and I still enjoy my job. So yeah, I don't think you need to be absolutely great at physics or maths to be an engineer. That's my thoughts anyway.
Thank you.
Yeah, I'm quite similar to Avi actually. So I didn't take physics for A-level because I didn't know that I wanted to be an engineer. So I took maths, ICT, and art, and I really loved art. Like, it was so creative and it was just an escapism. But then I got to university and I obviously didn't do physics, so I found it a little bit difficult actually in my first year, where everybody had taken maths and physics and kind of knew, you know, the basics of it. I just had no idea. So I struggled a little bit, but you know, what Abby said is completely true. I don't really use it in my job now. I probably use maths more than I use physics. And I use more like the, you know, computer softwares, which that's all I kind of need to get by in my job and to do my job well. So I agree with this, debunking this myth.
Yeah. Emma?
I kind of agree with this myth. I think like, it is important for engineers to have a good grasp of scientific principles and a good grasp of mathematics, especially if they're kind of, you know, applying those in reality. I think the bit of the myth that I don't agree with is the fact that this is the barrier to get to a career in engineering. Yeah. I think you know, when University College London or UCL brought in this, like, not a requirement, I think it was for both maths and physics at A-level. Obviously still like looking for a good caliber of students, but like they took that down. It tripled the number of women that they brought onto their course. So I thought that was interesting in terms of, and then obviously once people are at universities, making sure they have that competency in scientific principles and mathematics. I know for myself on a site, like I used to compete with the joiner around who could do arithmetic quicker. And you need to be able to have those kind of core skills, but you can learn them at university. It's not necessary that that is the barrier, that a decision you made at 15 not to do that A-level stops you doing an entire career. I think that's where I really disagree with it. And I think encouraging people who have creativity, I did art at A-level, and I think that, I'm not then saying I'm very, very creative, but I do think like bringing in like creativity and people who have done a different route is absolutely fundamental to increase the diversity of our profession, but also to just have like more real world perspectives. Yes. On solving problems, or identifying which are the problems that actually we should be solving together. So yeah, I think it's important to have a good grasp of principles, but this definitely shouldn't be a barrier for entering the profession.
I agree, especially now that there's other routes of engineering, so such as apprenticeships, etc., etc. I'm not sure if they, I know there's degree apprenticeships whereby you go to university at the same time, but I know the more traditional apprenticeships are just kind of just being at work and you learning on the job. And quite frankly, I don't remember the apprentice I worked with sitting there doing mathematical equations. So he's just kind of learning how to be an engineer, which I think is, again, as you were saying earlier, which is much more important than number crunching. You can number crunch any day, and you can kind of do that on the software, whatever. You can ask someone to teach you, but again, like we were saying before, I think it's more about the engineering and really understanding exactly what's going on, etc., etc. Yeah, I definitely agree with that. But again, it should not be a barrier, because I remember even when I did hear about engineering, thinking, damn, I don't know if I'll be great at this because I don't have maths and physics. And that to me was a really big barrier in my head, especially when I was going to study engineering at university in the next year. I said, wow, I'm not going to be good at this because I don't have maths and physics. But again, I'm in the place I am now, and I don't think I'm bad at my job. Well, I don't think I'm bad at my job. I think I'm actually still learning a lot. And there's a lot more on offer for me, and I didn't do maths and physics at A-level. So again, we shouldn't reiterate that story to the younger generation that you can't do this because you didn't do maths and physics. There are people out there who didn't and are doing extremely well. So yeah, I definitely agree with that.
I was just going to say, sorry,
you go,
sorry,
Abby.
I was just going to say,
really go, Abby, you go first, and I'll disagree with all of you.
I was just going to say the fundamentals. I think fundamentals for being an engineer is just being inquisitive, being someone that has to fix how things work. Yeah, that would be a lot more important, because that would definitely get you places. It would get you a lot further than just, you know, being great in maths or physics, because you will, I mean, as an engineer, not all problems that's going to be solved already have answers. So you are going to get to a certain stage, you know, if you go on to study engineering, where you don't have the answers. And if you're not inquisitive enough, or, you know, you're not creative enough to try and find answers to it, then you're just going to be stuck and you won't find a way forward. So I'd say, you know, and as much as it's good to have the basics for maths and physics and chemistries and, you know, some other sciences, it's always good to have that fundamentals of wanting to be able to fix things and how things work to be able to be a good engineer.
Mm-hmm.
You can't disagree with that, Rhys. You can't disagree with that.
Mimi, you keep on agreeing with everyone, so now you can disagree with me.
Go for it.
So I think we need to be really careful here. Like if you, so I'm not saying that you need to be, so the myth is to be an engineer, you need to be great at maths and physics. Mm-hmm. So the question of a great, you could argue. And I would also say, and the point was raised earlier about physics. So physics is a really, really broad subject, you know, and it includes nuclear physics, it includes, you know, particle physics, it includes gravitational, you know, astronomy and all those kind of things. And actually the engineering bit is a relatively small part of the total physics curriculum. But I think we shouldn't kid people that you don't have to be able to do, certainly for a degree level, which is what we're talking here, and particularly if it's a degree that would be accredited by an engineering institution, that would mean that you could become chartered at a later date. You know, there is a substantial amount of mathematics and physical concepts in the degrees that you have to get your head around. And if you remember, if you all cast your memories back to when you did your degree, you know, second year, third year mathematics in degrees it's not, you know, easy. It's quite challenging stuff. So I think we need to be careful not to kind of like create a kind of a myth that it's that you don't have to have any maths and physics. So you do have to have maths and physics to be a graduate professional engineer. The extent to which you'll use those in your career, as you've been pointing out, depends on the kind of role you do. Structural engineers who are going to sign off on that bridge or the tunnel or whatever will have to, you know, be able to demonstrate some quite sophisticated mathematics. The chemical engineer who's working out the kind of turbulent flows in an oil or gas stream or something like that, where there's mud and all sorts of slurries, you know, that can get quite complicated. The vast majority of engineers are not going to be doing that kind of stuff, but we should just be slightly cautious not to give the impression that you don't need any maths and physics, because you do to get through your degree, and you will need some maths and physics in your work.
Yeah, no, I agree.
You agree with me?
No, I do. No, I meant in terms of you do need the maths and physics, definitely to get through your degree.
You agree with me?
No, to get through your degree, definitely. 100%. But I just feel like if you feel that your maths and physics ability is not the greatest at university, then yes.
Mine was terrible.
Oh, no, mine was terrible as well.
I failed my maths and physics A-levels. I had to get a foundation year to get into university. Don't tell anyone that. I'm the director of education at the Royal Academy of Engineering, for God's sake. But yeah, but when you get to, you know, you do have to study. You know, you do have to put the effort in to get the math.
I agree. I think at university, like I had never done physics before. Like that's how, you know, bad I was at it, and I did really well at university. But I think that's mainly because I think it's common sense and it's working hard. And I'm a really firm believer, and if you really want something and you're really passionate about it, you will work hard. I used to, you know, spend honestly hours trying to figure out some of these fluid dynamics things that I'd never heard about. But if you dedicate the time and you're passionate about it, you will get it. So I don't think it's like necessarily like, you know, you don't really need to be physically, your mind doesn't need to be like straight into physics or maths. It can be kind of taught through, you know, all the stuff. And now that we've got the internet literally teaches you all your lectures in probably a 5-minute YouTube video. So, you know, if that helps encourage anyone, you should definitely use that.
And definitely, if you don't ask, you don't get. If you need help, ask your lecturers. They're there to help you. So that will be kind of like my final say on the topic, definitely. Should we go on? I
still have cold sweats waking up in the middle of the night thinking about Navier-Stokes equations.
Sure. Mine was Bernoulli. Definitely. I wake up at 3 AM like, but now I don't use the Bernoulli equation. So all is
happy days.
Should we go on to the next one? Let's try and get through the, yeah. We'll go through this one quite quickly. So it'll be myth number 4 is engineering is a man's profession. So I'll take maybe 2 answers from the panel. Who would like to go?
It is a man's profession, but it's not only a man's profession.
Good save. Yeah, I agree. It's not only a man's profession. I'm here. I'm not a man. There's many women in my office, and I think we all collectively work together to do something absolutely fantastic. Women and men, we think differently. Thinking differently doesn't mean that one is better than the other. We collaborate together to do something fantastic.
Yeah, I don't agree with this myth. I don't think engineering is a man's profession, only because it's not. It's just simple, and the fact it does look like it is because you've got a lot. It's a very male-dominated profession. However, there's quite a lot of females that are amazing engineers, that are invented in the engineering in the engineering space. And so saying that it's just a man's profession is something that, so I'd say the older generations think so, because a lot of people, when they think about engineering, they think about, you know, manual labor, they think about you know, people like all sweaty and dirty underneath cars and, you know, doing like proper manual stuff. Not saying that females don't do that too, they do, but that's just the idea that a lot of people have in their head. And so when they think about engineering, they don't necessarily think about the people sat in the air-conditioned office all day behind a computer, designing away, or out in the site, you know, like maybe looking at concretes and the composition of concretes and stuff like that. That, you know, it's not just men do. Everybody, men and women, both does it. And I feel like it's something. It's a view of engineering that is slowly changing, and so more females are embracing being engineers and going into engineering industry. It's going to take a while, but we are getting there. It's a lot better than it used to be.
Yeah, it's definitely better than it used to be. There's more numbers, especially in the construction industry. Slowly but surely, I feel like the numbers are slowly but surely coming up. Definitely, there's more women in my office. Not more than men, but I've seen, in terms of our new recruits, there's definitely more women coming in, which is always good, because I come in and I'm like, high five, yeah, we're both here. So, you know, it's quite nice. So, no, definitely, I feel like it's just something that's slowly changing.
I think one thing you find also is that some engineering professions are more female friendly, well, are perceived as more female friendly than others. So I work in food, and a lot of my business is to do with agricultural engineering and stuff like that. And a lot of people, there's not a lot of women in there, but that's just because it's perceived as a very male-dominated industry. But when you look at some other type of engineering, say, I don't know, electrical engineering or process engineering, you find a lot more females working in those type of profession, because it's a lot more feminine, it's a lot more female friendly. I remember studying at university, there was a lot more females in my engineering degree than there was in civil engineering. It's both engineering, it's just they like chemical better. But yeah,
that's so interesting. I've just jotted down literally my favorite engineers, and about 6 out of 10 are women. Jane Wernick, London Eye, and the Kew Gardens Skywalk, absolutely brilliant engineer. Sue Ian, she is Mrs. or Dr. Nuclear Engineering in the UK. She is the most you know, absolutely brilliant engineer. Dervla Mitchell, she is the Mrs. Airport designer. She designed Heathrow Terminal 5 and the new airport in Dubai. Eleanor Stride works with micro bubbles to release chemotherapy cancer drugs right where the tumors are, using kind of ultrasound to direct these bubbles through the body. Incredible. Anne Dowling has basically created the silent aircraft so that we don't have noise pollution from aeroplanes anymore. Joe Da Silva done amazing work in addressing sustainability challenges and homes, low-cost housing and things like that in developing countries. So many incredible women engineers, and we just don't celebrate them nearly enough.
I think you meant 7 because you missed me on your list, but that's okay. Next time. That's okay.
Sorry, Mimi.
Would you mind also sending me that list? I'd love to look into these ladies' work. Like, what you would describe just there is fantastic.
Totally.
Thank you so much. Should we go on to the next one? Just to think this is the last myth that we have. So there's no one like me in engineering. Who would like to go first? What does that mean to everybody first and foremost when they say there's no one like me?
So my daughter really wanted to be an engineer when she was about 9, but she said, I want to be a real engineer, not one like my dad, because he just drinks coffee and sits in meetings all day.
Uh-huh. That's not a bad job.
I really like it. So I wonder how many engineers spend their time in meetings drinking coffee. Probably quite a lot of them, but actually. So maybe I'm quite common, it turns out.
Anybody else?
I think for me, there is, it's, for me, I think this myth to me is, I would interpret it as saying there's not a lot of black female engineers like me in engineering, in which case I disagree. There is loads of us in engineering. I mean, if you're looking at like the wider spectrum and the wider population or workforce in engineering, I know most people, some people might have seen the movie Hidden Figures.
Yeah.
One of the first black female engineers that worked for NASA was, you know, she was a black female engineer. Her name was Mary Jackson, and she looked like me. She looked probably not exactly like me, but yeah, she looked like me. And I believe there's so many, you know, women in engineering, in all different sectors of engineering, all over the world, and it's not difficult. It's not going to be hard to find women like those. It's just, where are they hiding? Because they're not all being printed on the newspapers or, you know, being put in news articles all over the internet, but they do exist. And yeah, so I'd like to disagree with this myth.
Yeah, no, I agree with that. I was very inspired by Hidden Figures. They're already being in engineering. You can still be inspired by their engineers while still in engineering. So when I first watched Hidden Figures, which was maybe 2 or 3 months ago, I was like, wow, it kind of reminded me of why I'm still here and why my presence in engineering is actually very important for people who do look like me. So yeah, no, Abby, I co-sign you on that one.
I think for me, this is an interesting one. So when I was kind of younger, I wanted to do something like meaningful, like be useful. I was kind of principles that were instilled at me quite young on. So I was looking at nursing, I was looking at being a doctor, I was looking at physiotherapy, and I was wanting to do something that was like useful for people. And yeah, and then kind of hop, skip and a jump landed in engineering. And I think like finding people who have that shared value around like actually engineering designs the bridges and the cities and provides water and rolls out vaccines at speed. Like there's a huge possibility of the energy network, you know, the climate emergency, like in terms of providing hope for the challenges that we face as a society, whether it's racial injustice or environmental injustice, like engineering is a key part of that. And I fundamentally believe that like the values that like I have around like engineering should be serving all people on our planet better than ever before, I think is more shared than we talk about. So yeah, I have a lot of hope that there's more people that share those values in engineering. And I think that's absolutely key. And the final point on this is that we need that. It's really dangerous if, you know, we don't have the representation across the board in engineering. You know, I don't think anybody wakes up in the morning and says, today I want to design a racist algorithm or a sexist, you know, structure in terms of whatever it is, whether it's toilet design or seatbelts. Like nobody thinks about these things in terms of like, I'm going to do that, I'm going to cause harm today. But engineering needs to be really inclusive to make sure that the outcomes of what we produce, whether it is buildings or algorithms or water systems, you know, are actually going to work for society. So yeah, I think I've seen it on 2 lenses, like definitely inclusion needs to be, because we need like inclusive things that actually work for society, so you're not at risk of, you know, criminal incarceration or what that word around, kind of like because your face profile on an algorithm doesn't work, or, you know, you're more at risk of dying in a car because the seatbelt was never tested on a female body shape. You know, like I think we need that. So this is really, really key. But I've got a lot of hope because I think there's a lot of people in engineering that have that shared value around wanting to make this work for people and our planet. And I don't think everybody's just in it for, you know, I don't know why else you'd be in it, to be honest.
Yeah, no, you're right. I think as engineers collectively, we have a shared vision of a better world, whether that may be in water and sanitation and whatever sector of engineering people are in. And that has to be fit for everyone, fit for purpose. So yeah, you're right. We do have a shared vision. And if that's not inclusive, then this is not the right profession for that person who doesn't have an inclusive vision of the world that's fit for everybody and everyone who's in it, no matter race, gender, sexuality, etc., etc. If you don't have an inclusive vision, then I just don't think engineering is for that person in general. But yeah, thank you. thank you so much to our panel. That was the last question that we do have. We are going to go to our Q&A. So if anyone does have any questions for our panel, please alert us in the chat, or feel free to, I think you can allow to unmute if you want to actually say your question. One moment. Oh, I have a question here. So this is for anyone in the panel who would like to answer. Myth number 3 stated that you have to be great at maths and physics to do engineering, which the panel said is not fully true. However, most degrees at university only accept students who take maths and physics A level. If you only take one of these subjects, how would you apply for a degree in engineering?
I'll jump in.
Yeah.
So for me, it was more about looking at like the requirements for the university that I wanted to go to and I wanted to choose. And I won't, you know, put in black there and say, you know, you absolutely don't need any maths or physics. I think, like we all said earlier, you need the a good amount of, you know, maths and physics understanding of it to be able to get in. But some universities require maths and physics at A level. Some don't necessarily state maths and physics at A level. Some only probably care about UCAS points. I don't know if they still use UCAS points these days. So it's just researching the university you want to go and seeing what their entry requirements are. Not all of them will require you to have maths and physics, but some of them might do. And so that might help you, you know, sway your decision as to what university you want to go to, or what subjects you want to study for A levels.
Yeah, and I just add to that, actually, so it's a bit like the kind of ticket price. The ticket price is maths and physics at A level, but if you have a chat with the doorman, you might find that they don't need the physics, so you can get a discount. And actually, that's happening more and more. So actually, they really care about the maths. The physics they care less about very often. But you need to have the conversation with the kind of, so the admissions tutor is effectively the doorman. Yeah, have a conversation with them, because actually, if you've got the passion for engineering, if you demonstrate the interest, the enthusiasm, and the drive, then actually, you know, they'll probably do a deal with you on the physics bit, if that's the bit you haven't got.
And I think, like Steve put it in the chat box, but like, if look at the universities that aren't asking for that as well. So like TEDI-London, the degree course, I wish that was on offer when I was choosing a university to go to, frankly. Yeah, definitely have a look at the ones that are doing it a little bit differently, and apply.
I agree with that. And also, if you don't have maths and physics, they do offer foundation years for you to kind of pick up your maths and physics skills, which is another route into engineering. Or, as Rhys said as well, showing a willingness to learn. I'm not sure how you apply to university these days. Is it free? You still have to write a personal statement? If you show through a personal statement that you are passionate, willing to learn, even if you don't have, you know, the physics or whatever it is, I don't think they would say, oh no, because you don't have physics, it's not going to work. If you can show true dedication and willing to learn, I think willing to learn is just a skill that no matter what profession you go into, you need to show that you are willing to learn and persevere and show like a wider career within engineering, then you should be fine. And
clearing as well, that's another way.
Sorry?
I said, in using the clearing, UCAS clearing.
Yeah.
If that's still a thing. Yeah, that's another one. So most universities tend to lower their requirements during clearing. So that might be another alternative to studying engineering with one of math or physics.
You know what? Can I let the viewers into a secret that they probably don't know? Not many, the universities don't want to tell you. Universities are desperate these days. Universities are desperate to get more students in. There's a real competition. So if you haven't got the right thing, just say, look, I've got it. I can come to you, and they'll be like, oh yeah, I'll bite your hand off.
Yeah, agreed. Especially as engineering is becoming a profession that's needed. We're strongly needed in the world. So I agree. If they're desperate, they will. There's another question that we have.
Just before that, I've seen a lot of the unis now. They're really looking at your maths grades and physics grades. So I'd say the top Russell Group ones.
Yeah.
I don't really see there's any like other way around that right now.
As in, sorry, you said the Russell Group universities.
You know how you were saying that you don't necessarily need to do physics to do the engineering course? So
for Russell Group, they will definitely, I think those are the universities that are kind of still in the old way of doing things where they definitely won't be budging. So I would, as Abby said, look into the university that you're applying to. If it's the Russell Group, they will definitely want to see a good mathematical and physics ability. However,
not true.
Really not?
Myth busting, not true. For Emma mentioned earlier that UCL, civil engineering, don't require maths or physics A levels. They want high attaining students. They'll take, they want to see A grades and real, academic attainment, but it doesn't necessarily have to be in maths and physics. Other universities are definitely experimenting with this, and certain departments within engineering universities are experimenting with it. So Imperial College London, for the design engineering course at the Dyson Design Centre, don't require maths and physics. So you have to look around, because you'll be surprised. A lot of the other universities kind of lower down the Russell Group. So Liverpool University don't require physics. I think there's a few kind of mid-ranking universities don't require physics. Again, have the conversation with them, because they'll say, you definitely need math and physics, but I think they'll be open to discussions on that.
My apologies.
Beanie, could I just add on that question, and thinking of your consideration of university, I think it's some of the things that the panel mentioned earlier as well, of not just those entry requirements, but what's the type of program you want, in terms of, as Mimi said for herself, in doing a placement, TEDI-London, doing lots of projects. So think of also what's that makeup of things, so not just those entry requirements to things, but what is the type of experience that you want at university? So that also goes to campus, whether you want a city experience. So consider all of those aspects around your university decision, or apprenticeship if you take that route.
Yeah. I just want to mention that.
Also, the Russell Group isn't the be-all and end-all. I think this is really important. And there are some really great universities outside the Russell Group offering engineering degrees. And in fact, I'm doing a project at the moment with Lewis Hamilton. You may have heard of him. And he's really keen to improve ethnic diversity in motorsport. And so we're talking to a lot of the F1 teams at the moment. And they're really keen to reach out beyond the Russell Group, which they've traditionally gone to, because they recognize that there's actually really great talent in other universities that they haven't been exploring. And lots of other companies are doing that as well. Lots of kind of major consultancy companies like Mott MacDonald, like WSP, like Arup and other organizations. They're looking beyond the traditional Russell Group universities to find different types of talent and different skill sets and different ways of learning that have been had by lots of different engineers.
Yeah, that's true. I agree with that. I think you should, as was said before, look for the program, look at university, look exactly what they're offering, and see if that's tailoring to your needs. I think that's what's really important, rather than saying, I'm going to go to Imperial because it's Imperial. Is Imperial right for you? Is it to follow the degree program you want? Is it going to lead you to the career that you want? I think that's what's most important when looking at university as well. So there's another question that we have from the audience, which is, what is the normal day like for an engineer? Who would like to go first?
I think it's a really interesting question, that. So I've worked in both the design office and a construction site. I think the key thing is that there's a lot of team working. So you're normally in a project team. So if you are a civil engineer, you're normally working with other disciplines quite constantly. If you're on site, then you're probably working with other trades, all the different moving pieces on a construction site. So I think teamwork is absolutely key. So a typical day, in a design office, would be probably coming in, looking at some drawings, understanding the project or projects that you're working on, talking them through with other designers, maybe getting them reviewed and checked, working them through with the construction team to make sure they can be built properly, talking maybe and presenting that information to the client, on looking at like the hazards in the next 50 years when they're operating that site, and 20 years on. So yeah, there's a real variety, and I would say that like every day is a bit different, and that's what I really appreciate about engineering, is the variety that you get to see and the different types of people you get to meet.
Definitely, especially I can co-sign from being on site. I spend most of my day in the site office or just on site in general, and most of my days speaking to people and checking if the work has been completed on time, and to program, collaborating with all different trades. And it's most of my days, hi lads, and how's it going, and just really trying to also not just making sure people do the work, because if you continuously micromanage people, they may not have the output that you want, but also having a good time. So I spend a lot of my day as well not just saying, please make sure you've done this, I'm begging you, please have done this, but it's more of having general conversation as well. Because also it's about the way you speak to people, like we said before. So yes, I ensure the work has been done, but I also like to ensure that everyone that I'm working with is having a good time. So it's not just us sitting at the computer, tapping away, being bored. Yes, we spend quite a bit of our day doing that, but also we do laugh and we do go for coffees, we do enjoy, and we do speak to each other, whether it be about the work or other things, but you are able to multitask and do your work as well as have fun at the same time, which I think is very important. And that's another myth behind that I've heard people say to me behind engineering, oh, I bet the office is dead silent. Well, no, my office is not silent at all. It's full of laughter, whether people are talking about the work, whether they're screaming at each other, or whether people are just genuinely just having a chit chat and having a good time. So it's kind of what you make it the day, I suppose. No one else?
So I've had a slightly different. Oh, go on, Abby, you go first.
Oh, sorry, I was just going to say, conscious of time. Mine is very, very different because I'm a process engineer in the food manufacturing. So my day, my normal typical day, is very different every single day. Because my main role is to make sure that all the equipment effectively running well and there's no downtime and things are done safely. And so every morning would go and review the day before and said what went well, what didn't quite go well, and if there was any issues, plan to get it fixed. And also working in teams of different people to work on ways to improve what we currently have in ways that can maybe make it safer for people to work with equipment, or save money, or improve the quality of the product that we're making. So every day is quite different. I spend a good amount of time behind a computer replying to email, quite lots of emails. You said lots of emails as an engineer, and being on plant, working with physical stuff and valves and pumps, and yeah, it's very exciting and fun. But it's very different.
Thank you. Rhys, did you say you wanted to say something as well? Sorry, it's on mute.
Ah, damn it. No, it's fine.
Okay, thank you. Well, thank you so much for that, Abby. We have one more question, and the question is, for engineering design, does it require you to be good at art/drawing? Well, I cannot draw and I'm not good at art. So, but then again, that's not really part of my role. It's not, I don't or anything. I look at concrete, so probably don't need it. If that's anybody else, do
I think drawing's mostly, like, in my experience in construction and mechanical, it's lines. So it's just CAD drawings or 3D models. So you could be really good at hand drawing, but that is not reflective of what we do in industry. But the main thing I would say is, if you're good at art and drawing, is that it's your creative ability. Yeah. It's your ability to approach a problem in a different way, or to slightly see a different angle to your colleagues. So, it's not necessarily about actual physical drawing, but more about how you think about it.
Definitely.
Yeah, Neera nailed it there. It's all about your creative thinking processes, idea generation, and problem solving. It doesn't have to be about beautifully constructed drawings and things like that. It's about the process of the mind in trying to tackle a problem.
And actually, in the beginning of most design processes, most of it is a quick hand sketch, which aren't the nicest. So, and then that gets adapted onto detailed design, and it becomes a CAD drawing.
And we don't spend enough time doing like really rubbish sketching, actually, in engineering. Certainly, you know, the way we teach engineering students, actually, more should be done to just do a really rubbish sketch and then move on to another really rubbish sketch. But anyway, that's another conversation. And
I also feel like as well, when I do my really rubbish sketches in the beginning, I find I learn more by trying to explain to my manager, actually, no, that's meant to be this, and then that's this. And you kind of learn more by talking about your thought process about how you've come up with this design.
Yeah, absolutely.
Yeah, definitely. But no, not physical art drawing. No, I don't think so. More about creative processes, like has been said before.
Mimi, a really important question from Elif, which was, how can you figure out which part of engineering is for you?
Oh, good question. So
I think that's a really important one.
Sorry, my apologies. So this will be the last question then. So guys, how do you figure out which engineering is for you? I'll go first. Mine was about risk. I was things on the whim and taking a large amount of risk. Now, I'd never heard of civil engineering until I went to that lecture that I was talking about. I didn't know about any of the other forms of engineering. The first year was about civil engineering, and I just like the sound of it. So sometimes I think not everything in life has to be extremely calculated. Just kind of, for me anyway, I kind of do things if I like the sound of it. And I think, okay, I can see myself doing it, especially when I sat down in that lecture and they were talking about bridge design. And I went, wow, I can see myself designing bridges. And that was it for me. And I went, okay, this is what I'm going to do. And I haven't changed my mind since. Even though I've heard of all the different other engineerings now, I still always will run back to civil because it's one of my loves, I suppose. So if you have an interest in something, there's definitely an engineering for it. So if you're interested in makeup, you can go into cosmetic engineering, I think it's called, or is it chemical engineering? Or if you love cars, there's motorsport engineering, or there's motor engineering. There's an engineering for everything. So that's how I would deduce which engineering to go into. If you like something, there's usually an engineering for it.
I love that you said civil engineering is one of your loves. That's
it is.
Great.
Oh, I love a bit of concrete.
Reinforced, steel reinforced?
Yes, ultra performance fibre reinforced to be exact.
It's a really good question though, and I think Mimi's approach is very kind of high stakes and serendipitous, and I'm not sure I would definitely suggest that to everyone. I think there are lots of ways of finding out more about the different engineering disciplines. Tomorrow's Engineers is a really good website. This is Engineering, so the Royal Academy of Engineering runs a campaign called This is Engineering, where we have loads of different young engineers doing different types of engineering jobs, and you can see, and they have lots of interesting case studies, and you can listen to them talking about their day jobs, and so that's quite a useful resource. But yeah, I think you have to kind of work out what you're interested in. Electronics is going to be sitting in a room on a lab bench, working, whereas Mimi's job is out on site or designing huge kind of structures. So you kind of have to know a bit more about all the different engineering disciplines, and understand the kind of skill sets and things like that you need for each of them.
I agree.
I would also say that you don't really need to figure it out as soon as possible, because although I'm mechanical background and I realized I preferred civil engineering, I found it more interesting, and it was like I felt like I'd missed out on an opportunity. But I'm now a chartered mechanical engineer, but I work on construction projects, and I get to be involved with concrete and pipe jacking and all these things that I find really interesting. Aren't my degree, aren't my background, isn't what I'm kind of what I've learned in, but I'm working in it now. I guess the important thing is that with any engineering, your skills are transferable and you can kind of move around within reason. So I can now start looking more into civil engineering, and if I wanted to be a member of the Institute of Civil Engineers, I could do that. A lot of people have dual accredited backgrounds. So it you know, it doesn't need to be, you don't need to choose right now and right here. And the important thing is that there is a baseline that everyone sort of learns the same sorts of things at university. It's just when you specialize in it, and that's when you kind of, you know, hone into your specific civil specific degree choice.
I was just going to say, sorry, if I could very, very quickly, asking people, if you know engineers, people that are in your family or network or on LinkedIn, or, you know, just ask people, just ask them as an engineer, how do you like it? What do you do? And loads of people want to tell you about their job. They want to tell you about their job. So if you just go and ask people as well, I think that's another really good way of figuring out which part of engineering could be for you, and then finding out if you can maybe shadow some people, so maybe 2 weeks or work placement or work experience to test the waters as well. I think they go a very long way to help you decide which type of engineering you want, you know, could be good for you.
Thank you for that, Abby. Emma, did you have anything to say?
Yeah, I guess when thinking about what parts of engineering you want to work in, it's maybe also worth thinking about, like, what do you want to do with your career? Like, what impact do you want to have in the world? What things do you want to get out of bed in the morning for? So kind of thinking about, do you want to help the transition from oil and gas to renewable energy? Do you want to be part of, you know, designing the cities that people walk in terms of, you know, because that's actually changing people's lives. So like, I guess kind of thinking about the impacts as well. Like, do you want to provide water to people who do not have current access to reliable and trusted water supply? So kind of, I think for me, I work at an engineering charity, and being able to meet the broad range of people who have like a passion for an area or have a really interesting job in terms of what they've done, I would start with that almost, and kind of looking at what are the different things I want to do, and talk to people and hear some interesting stories. And completely echo the kind of This Is Engineering campaign, and kind of learn and hear different types of stories about what engineers can do, and kind of dig the really, really interesting ones out.
One final point, if you can't make a decision, then keep your options open. Do general engineering degree, and that will give you a little taster of all different disciplines. And then in the third year, you usually specialize in the discipline you're interested in. Yeah,
that's a good way as well. Well, I think, that was it. So thank you so much to our panel for debunking all our myths and answering all our questions for the Q&A. I really had a good hour. We've gone over by 15 minutes, but I think it was well worth the 15 minutes. And I really, really appreciate all our participants for attending. Please stay in touch with TEDI-London. On the screen, you'll see all of their communications. And also please stay in touch with BWeng. They have Instagram, and that's our email address there. And again, thank you so much. I'll pass you over back to Helen.
I've got nothing really to add other than to say a massive thanks to all of our panel and to Mimi for a great job chairing that. I really hope that all of our audience enjoyed the chat as much as I did. And yes, do stay in touch and do look out for further events. I look forward to being able to do this with you all again. Thank you very much.